All right, so in 12.5, we're going to look at problem solving with the normal distribution. So what we're going to learn how to do is solve applied problems involving normal distributions. So this means we're going to look at problem solving using z-scores and percentiles. So if the heights of adult females in North America are approximately normally distributed with a mean of 65 inches and a standard deviation of 3.5 inches, suppose we're interested in the percent of adult females with a height below 73.5 inches. Well, what's our z-score? Well, we take our data item, 73.5, minus the mean of 65, divided by the standard deviation of 3.5, and we get a z-score of 2.5. Now, this z-score is not an integer, so we can't use the rule we used in the past, which was the 68, 95, 99.7 rule. And it's not helpful for finding something with the 2.5 or any other number besides ones that fall within this range. Okay, and so what we're going to do in this section, we're going to use this table 12.7, and it's got z-scores left and right, and then we can solve a variety of problems with it. Now, the table looks like this, so it's pretty full. And so we have the negative z-scores here, and then it goes up until we hit the 0, which is our mean. And then it has positive z-scores until we get to 4. So it goes from -4 to +4. And so we're within 0.003 at this one as well as this one. And so what happens is, like if we are at a z-score of a negative 0.8, then that means the percentile is 21.19% of the people are below that. Okay. Or if we're all the way at the, what was it again, 2.5, well, 2.5 means that 99.38% of the people are going to be, or the females are going to be below 73.5 inches. So that's how this table is going to work. And I'm going to pull it up, ever so often, and it's going to, because we're going to have to use it. So hopefully we'll be able to start understanding how to use this table with not only just one score, but sometimes we're going to look at between two scores. All right, so the portion of the table in the margin indicates the corresponding percentiles for a z-score of 2.5 is 99.3, like I mentioned. So that means 99.38% of the North American females have heights that are less than 73.75 inches, or a z of 2.5. Now, in a normal distribution, the mean, the median, and the mode all have a corresponding z-score of 0. Now, table 1217 shows that the percentile for a z-score of 0 is 50, which means 50% of the data items in a normal distribution are less than the mean, median, and mode, and consequently, 50% have to be greater than the mean, median, and the mode. Now, this table can be used to find the percentage of data items that are less than any data item in a normal distribution, and we begin by converting the data item to a z-score, then use the table to find the percentile for this z-score, and then this percentile is the percentage of data items that are less than that item in question. Okay, so again, like I was saying, here's that mean, median, and mode, and so this is going to be our percentile, or 19.77% of the people are going to be less than a z-score of -0.85. So that's how we're going to be using this. So let's look at this example. It says the distribution of monthly charges for smartphone plans in the US is approximately normal with a mean of $62, a standard deviation of $18. What percentage of plans have charges that are less than $83.60? All right, well, Z is equal to what? Well, we want to look at 83.60 minus our mean, which is 62, divided by our standard deviation, which was 18. All right, so we use our calculator. And so now we have parenthesis 83.6 minus 62 divided by 18, and we get 1.2. All right, so 1.2 is our z-score. So we want less than that. So if we go to our table here, 1.2, 88.49 is the percentile. So that means 88.49% are going to be less than $83.60. So that's going to be the percentage that are less than that amount. Okay, so that's how we can use our z-score to figure out the percent less. All right, so let's stop there and we'll come back for some more.